Welcome everyone. We are going to begin the webinar on electric vehicle safety presented by GMG. I'm Melissa Joles with RDA Impact. Kevin Dwyer, Senior Compliance Coordinator and Certified Safety Manager for GMG EnviroSafe is your presenter for today. Presentation will take approximately 30 minutes. We are recording it and we'll post it on our YouTube channel. And I'll also send it to everybody who participated today. If you have questions during the webinar, you can type them in the chat box, bottom right of your screen, and Kevin will answer those at the end of the presentation. Now I'll turn it over to Kevin.
Hello everyone, good afternoon. This is Kevin Dwyer from GMG EnviroSafe. Thank you for taking the time out of your busy day to join me. Thank you, Melissa from Refinish Distributors Alliance for setting this up to give me an opportunity to speak with all of you. I hope you and your businesses are doing well and staying safe. Today we are going to talk about electric vehicles. Get excited, the future is here. Some headline news across the world forecasting the growth of electric vehicles. Across the American fleet, we've got investment bank UBS has predicted that 20% of all new cars will be electric by 2025, only 3 years away, and 50% by 2030, only 8 years away. American Honda is committed to having electric vehicles represent 40% of sales by 2030 and 80% of its sales by 2035. Volvo has pledged that 100%, yes, every single car that they are going to manufacture will be hybrids or electric vehicles. GM is investing $35 billion into EV technology, and Ford is investing $30 billion. Now, as sales of electrical and hybrid vehicles increase, the need for greater electrical vehicle repair safety has increased too, so that you at your shop are able to protect your techs and your employees from injury. Now, before I dive in, just a quick disclaimer about myself and the company. GMG EnviroSafe has been providing OSHA, EPA, DOT compliance expertise to the collision industry for over 30 years. I have worked as a senior compliance coordinator with GMG for more than 7 years now. I'm a certified safety manager based out of Philadelphia, and I've been heading up this project for the collision repair industry to develop more resources and educate the industry around electric vehicle safety. It's important to know everything that I'm going to be presenting you today is from GMG EnviroSafe, but we are not legal counsel and I am not an attorney. So this presentation should not be used as a substitute for legal advice. Okay, so this will take us to the webinar overview. In terms of today's agenda, primarily, we want to make sure that you as a shop owner or manager are aware of the hazards that can happen to employees that are exposed to energized parts. We want to make sure that you are able to identify the required personal protection equipment and safety devices that you need to have at your shop so your employees can repair these vehicles safely. And we also want to review the safety precautions that need to be taken to prevent electric shock. What we're talking about here is procedures, signs, posters, training classes, documentation, that sort of thing. I know there's been a lot of content out in the industry through the trade press, a lot of different details around EV safety, and a lot of it's coming from the OEs. We want to make sure that you as the employer, shop owner, have the most accurate, up-to-date information because you're not going to be fixing just one OE's type of vehicle. You might be a certified shop, but we're going to see again across a lot of different manufacturers, more of these vehicles are going to be coming to your facility that's just not a single OE. So before we get into specifically procedures and equipment, let's start with what an electrical hazard actually is. How do we define something as an electrical hazard? Well, first, it's a dangerous condition, essentially, that if you were to come into contact with a particular part or wire or something like that, or if you had some type of equipment failure, you could be shocked, you could have a thermal burn, an arc flash burn, or it could actually result in an explosion or a blast. And when it comes to electrical hazards, there's an important distinction between a qualified employee and an unqualified employee. And so you as a shop owner have to make sure that you are identifying which employees fall into these two buckets and that you are training to that specifically. Qualified employees are the technicians that are permitted to work on or near the exposed energized parts of an electric vehicle. Now, it doesn't mean that we are just repairing any electric vehicle. We're specifically talking about the high voltage system because these qualified employees have to do a number of things. They have to know the hazards that may be faced when working on or near exposed energized parts. So what we are doing today, they would need to go through a similar training like this, so that they know what the hazards are. They have to have the skills and techniques necessary to distinguish between an exposed live part from other parts of the electric vehicle. And most importantly, they need to adhere to those manufacturing operating procedures. This would include the use of testing equipment, shielding materials, insulated tools, and PPE. Now, we've seen this handled a lot of different ways in the shop, as owners have tried to build processes around this. Certainly, a lot of your traditional body technicians are being asked to fulfill this role of a qualified employee that's doing the de-energization and re-energization process. We've also seen shops that have set up dedicated technicians that only do electric repairs. We see that commingled with, ADAS or calibration techniques. And then we see other facilities out there that are subcontracting or subletting this out to dealerships or local vendors as well. If you as an employer or a shop are going to have these qualified employees, you need to differentiate who has the ability to de-energize, re-energize, or have contact with those exposed energized parts. Everybody else, if they are not involved with the high voltage system, then they are going to be those unqualified employees, which basically says they are not permitted to work on or near the exposed parts of an electric vehicle. So yeah, the ones that are gonna jump out to you to be unqualified employees, it's going to be your administrative people, your CSRs, your service writers, that sort of thing. But your other unqualified employees, they're probably going to be your disassembly, reassembly technicians, maybe some of your body technicians that are not involved in this process. Certainly your painters, your preppers, your detailers, your buffers. They might work on an electric vehicle, but first it would have been put in electrically safe condition before they start to work on that repair. So why is an electrical hazard an electrical hazard? What can it do to the human body? Well, it just depends. Electricity and the electrical current can do a lot of different things depending on the strength of current, the path, how long you're in contact with the energized part, just the physical body mass of the individual, and even moisture is going to change the physical response to electric current. But most importantly, we have to understand that a low voltage does not imply a low hazard. In fact, 16 milliamperes is the maximum that an average person can grasp on an energized part and still let go. Now, when you consider that most household circuits are 15 to 20 amps, that's 15,000 to 20,000 milliamperes. So even though we might be very comfortable with electricity in our own homes, we have to remember from a safety standpoint, we have more fatalities at 110 volt currents than we do at all other current levels combined. And now when we translate that to electric vehicles, the batteries themselves, they can carry a charge of at least 300 volts, which is lethal. That's enough to cause a fatality at your facility. And that would be absolutely devastating if that were to happen. So a shock from an electric battery is capable of causing a fatality or death, but also just injury from electrocution. We could have burns or explosions. There could be chemical hazards, or there could be secondary injuries where somebody becomes exposed to an electrical hazard. They get a slight shock and then they fall over backwards, or have a laceration because they grab onto something, what's typically known as a secondary injury. Now, vehicle comes to your shop. What do I do with it, right? Well, first thing is we really need to identify and differentiate at the facility that this is an electric vehicle. We can't just rely on, well, this is a Tesla. Everybody knows that Teslas are electric vehicles. We have to make sure that we are communicating as more vehicle manufacturers are producing fully electric and hybrid vehicles. And then we have some type of a hazard communication or a placarding system. We've seen shops that have put placards that are on the rear view mirror. We see them on windshields that are a part of their blueprinting process. There's a lot of different ways to slice it. Most important thing is that you're just consistent at your facility, and that is as soon as the vehicle arrives, before you even bring it into your facility, you're identifying that, hey, this is an electric vehicle with a placard, a sticker, and some of the shops that have done a really good job with this, have also added a color tag to the key fobs so they know how to quickly identify which keys belong to which vehicles. Now, one of the most important steps is if an electric vehicle comes to your facility, first thing we have to do, and before we start the estimatic process, we have to ensure that we are not bringing a battery that could be compromised, could be at risk of thermal runaway, and could cause building destruction from a fire and potential employee injury. And how we do that is we use a non-contact infrared thermometer to determine if that damaged battery is heating up. That could create a thermal runaway event. So depending on the vehicle, we can take that thermometer and we can place it under the hood, near the vehicle control module, or in the trunk where the junction box is. To identify, first, we have to take a baseline. What is our internal temperature of that battery? And then shortly thereafter, maybe 15, 20, 30 minutes or so, we're going to take another reading just to make sure that it isn't currently heating up. There's been a lot of confusion out in the industry about isolation zones because typically you're talking about 50 plus feet. Shops are busy around the country. We have a lot of WIP. There isn't a lot of room in the parking lot to create these types of isolation zones. So having a vehicle check-in process is critical. So you're not putting every single electric vehicle into an isolation zone because you're not going to be able to keep up with that type of WIP at your facility. We still have to make sure that we are not creating employee safety hazards or having an electric vehicle go into thermal runaway and catch on fire inside of our facility while we were doing the estimating process and then putting lives at stake. So what is a thermal runaway event? Essentially, a thermal runaway is when we have an increase in temperature that changes the conditions in which it could cause a further increase in temperature. So basically, these batteries have individual cells that are tightly packed against one another. And as a chemical reaction occurs in, let's say, cell number 1, it starts to get a little bit hotter. And that chemical reaction continues and continues and continues. It gets a little bit hotter over time. Eventually, it gets so hot that it triggers a chemical reaction in the cell that's right next to it in the battery pack. And then that process continues. Gets a little bit hotter until it triggers a chemical reaction in the cell that's right next to that one. And then you can imagine just going along down the line that triggers this fire. So we have these types of extraordinary events in the collision repair industry, which we were talking about, physical damage, crushing, tearing, any type of puncturing, water getting into the battery, or maybe the ignition, reignition of the battery after a fire can lead to this thermal runaway. The problem is it is not easy to put out one of these fires. If you've seen any of the videos on YouTube of the first responders trying to put out a fire of an electric vehicle that's on the side of the road somewhere, I mean, the amount of water that it takes to get this done, you're not going to have this at your facility. You're not going to be able to just use a traditional ABC fire extinguisher and put it out. You're going to have to call the fire department to come out. Another giveaway, if a vehicle shows up hissing, battery leakage, smoke, sparks in the battery area, it's a good indicator that we might be at some kind of risk of thermal runaway. Okay, so we've identified that the battery is heating up, and we have a possible thermal runaway situation. So we're going to move the vehicle to an outside isolation zone and contact the fire department immediately. Then you're going to want to make sure that the isolation zones are unobstructed and easily accessible by the first responders. So we've created this tool as a simple solution to help you work safely on EVs. We've covered the first two decisions. If there's hissing, smoke, or sparks, or the temperature is increasing, immediately relocate the vehicle to an isolation zone and call 911. If not, there's still important items to check. First, is there exposed wiring, damage to the vehicle's battery casing, undercarriage, charging point, electrical cautions on the vehicle's home screen, any fluid leaks. If any one of those is a yes, it's not an immediate, hey, yeah, got to call 911. You need to monitor for thermal runaway. So essentially, your authorized or qualified employee should wear the high voltage PPE that we're going to talk about here shortly. They'll de-energize the vehicle, they'll relocate it to the isolation zone, and then you'll monitor for thermal runaway, meaning you should be checking the internal battery temperature probably every 30 minutes to an hour, just to see if you're having any kind of increase in temperature. And if it does go up, then we're going to have to call 911. If it doesn't, then these are no longer hazards and we are not at risk of thermal runaway. We can bring it into the shop and proceed with the estimatic process. Now, if the answers are no across the board, I don't have any exposed wiring, I don't have any damage to the battery casing, I don't have any electrical cautions on the home screen, don't have any fluid leaks, and then there's really no reason to de-energize the vehicle. It's not an electrical hazard at that time. So you could bring it into your facility, into your estimating bay, and start to write your estimate. This particular decision tree, for anybody that's on the webinar, it's also available on our website. There's a direct link on the resources tab that you can click on. You guys can download this. You can build it into your intake processes starting today. So hopefully this helps and makes it a lot easier for you. Okay, so now transitioning, we've got through intake, we've written our estimate. Now we're talking about the actual repair process. So first and foremost, about the qualified, unqualified employees, we want to make sure that the technicians are in the qualified bucket. Those that are asked to do the repair work on the battery or the electrical system of the electric vehicle. They should not have pacemakers, insulin pumps, defibrillators, basically medical devices that they're depending on for their lives that are electrical in nature. Because not only are they potentially at risk of an electrical hazard, but these systems could fail if coming into contact with some kind of electrical component of that vehicle. A second consideration when it comes to repairing the electric vehicle, when involving the high voltage system, is we tend to carry metal objects in our pockets. The one that jumps out to me is always the cell phone. But certainly in our collision repair industry, we see money clips, we see keys, pocket knives, those types of things. Before we start to interact with a high voltage system, we should be removing all of this from our person. Metal is a conductor, and there's a chance that we can conduct electricity from the high voltage system while trying to do de-energization, re-energization, or if there's some type of exposed energized part and it triggers some type of electrical hazard and shock. Now, from a PPE standpoint, what do you need to have at your facility? So for the qualified employee that needs to do de-energization, re-energization, first we need lineman's gloves. These are going to be the rubber insulated gloves. We want to have class 0 so that we have enough protection for the type of battery sizes that are going to be coming into your vehicles. That's going to protect against electric shock. The outer leather gloves that you see on the screen, these are going to be covering the rubber insulated gloves. Dielectric overshoes to prevent your feet from completing electrical circuit with the ground, and an arc flash face shield to protect from burns caused by an electrical arc. Rubber insulating gloves must be sent to a testing facility to be retested and certified every 6 months. Before each use, you're going to confirm the gloves have been tested within the previous 6 months by reviewing the stamp and inspect for damage. You see the stamp there on the glove. It's the yellow stamp in the picture. That's what it looks like. Gloves can be sent to a lab via Granger, or you can send them to the North American Independent Accredited Laboratory local to you. And you can find a NAL lab on their website. It's a real easy process. You just ship the gloves to the lab, they test them, they recertify them, they stamp them, and then they just ship them right back to you. Pinholes, tears, punctures, or expired gloves can result in electric shock. Do not use rubber insulating gloves that do not pass the inspection. Lineman gloves can be tested before each use by completing an air test or a roll-up test. There are inflator kits you can buy where you can place the glove on an inflator and look for any leaks passing through a damaged glove. You could also do the roll-up test where you roll the glove up until it's inflated, and then you look to see if there's any air leaking through a pinhole. Do not test lineman gloves using compressed air from the shop. Compressed air can cause pinholes and damage to the gloves. And you're going to want to check the outer leather gloves to ensure they don't have any metal shavings or grease contamination on them. Only use insulated tools for electric vehicle repair to prevent sparks or a component short if the tool is dropped. With the multimeter, you are going to need a multimeter that is rated up to 1,000 volts. That'll be used to test the battery voltage level. Safety rescue hook must be in the immediate work area when working on or near the exposed energized parts of an electric vehicle, especially during de-energization or re-energization. Rescue hooks are used to pull individuals to safety in the event of electric shock while protecting the rescuer. Once the vehicle has been de-energized, standard PPE should be worn based on the work being completed, such as safety glasses, gloves, and respirators. Okay, so now we're going to get to the really exciting part, right? So how do you de-energize this high voltage battery? So getting into de-energizing the vehicle, prior to de-energizing the battery, like always, we're going to make sure we review the manufacturer's instructions, then store the key fob away so you don't cause an accidental startup of the vehicle, and put on all required PPE. Key fobs can be stored in lock boxes, just a real simple solution to have a lock box for the key fob, or you can store them in a separate area. Then disconnect the charging equipment, charging cables, and low voltage battery. Lower the driver window down for future access to the vehicle since the battery will be disconnected. Next, confirm your multimeter is working properly by connecting it to the low voltage battery. Do not proceed if the multimeter indicates higher than 14 volts or lower than 10 volts. Once your multimeter is confirmed to be working properly, confirm the ignition and ready lights are off on the dashboard. Then follow the vehicle manufacturer's instructions to de-energize the high voltage battery. After that, wait at least 15 minutes, yes, 15 minutes, to ensure all residual energy stored in the vehicle's electrical system has dissipated. Once completed, confirm the high voltage battery has been de-energized with your multimeter, and then you can go ahead and you can proceed with repairs. So that's how you de-energize that high voltage battery. It's actually a pretty simple process once you start looking at it and get into it. And now getting into the vehicle repair process. Okay, so once the vehicle has been de-energized, standard PPE should be worn for the remaining repair procedures. The de-energized electric vehicles should then be placed onto car wheel dolly jacks. This will prevent them from rolling tires, re-energizing the battery accidentally while moving the vehicle in the shop. Be sure to check the cables using a high voltage insulation tester. Leakage in these high voltage cables can cause injuries, electrical shorts, and fires. Some vehicles like Teslas will have a service mode. So service mode is a pretty cool feature. It stops the owner from being able to start the vehicle from their mobile device during service. However, we have to keep in mind that service mode is not a substitute for de-energizing the vehicle. Getting into painting and welding. Now, before welding or placing the vehicle into a spray booth, review the manufacturer's instructions. Some high voltage batteries must be removed to prevent high temperature exposure. OEM procedures will explain the maximum bake temperature and duration of time an electric vehicle can be in a booth. You're definitely going to want to take a look at the OEM procedures because there isn't just a set number across the board for all electric vehicles when it comes to bake temperature and time. Okay, re-energizing the vehicle. So now the repair work is done, and it's time to re-energize that battery. Prior to re-energizing the battery, review the vehicle manufacturer's instructions, store the key fob away from the vehicle. Again, you can put that in something like a lockbox, and put on all required personal protective equipment. You're going to ensure all disconnected wires and components are reinstalled and connected before re-energization. Recheck the cables using an installation tester to ensure they were not damaged during the repair. Moisture seals should be in place on connectors with locking devices completely seated. And then just follow the vehicle manufacturer's instructions to re-energize that battery. Okay, so what do you need to do with your hazard communication to prepare your shop for electric vehicles? What kind of documentation do you need? So you should update your job hazard assessment and the hazard communication program to include electric vehicle safety and the personal protection equipment required. In-depth training on electric vehicle safety procedures should be done for technicians working on the vehicles, which would make them qualified employees. Remember, we spoke about qualified employees and unqualified employees earlier. And then general awareness training should be conducted for those unqualified employees. Documentation such as training certificates should be kept, showing which employees participated in which trainings. And OSHA will cite the employer by observation or interviews to determine if the employer does not have safety procedures in place. We here at GMG EnviroSafe, we offer online training for both qualified and unqualified employees. So if you would like more information or need more assistance or need assistance with protecting your employees, business, or community, we are here to help. Your compliance department is our signature program where GMG EnviroSafe becomes part of your team so you can get the expertise, the resources, and the peace of mind that you need. Our most popular program is the Advantage program. That gets your shop all of the written plans, all of the training, all of the support, and a local compliance coordinator will visit your shop 4 times per year every 90 days, and that's for around $200 a month. So with that, if you guys have any questions, you can put them in the chat box now. And then I've got my cell phone number and email address on the screen if you need to reach out to me directly. So Melissa, I will turn it over to you for any questions.
Also, just want to let everybody know, not only did we record this, but I'll send you a copy of this PowerPoint. I know there's a lot of slides that you can get information as well as go to GMG site and get the information there too. Is OSHA really cracking down on the shops on these electric vehicles?
So they're going to eventually start cracking down. Right now, we haven't seen too much, but it's really not out there. Once it starts getting out there, and then you start seeing injuries from it, that's when they're gonna start getting notified of it, and then they're gonna eventually create a program where they're coming into the shops. That's usually how things happen with OSHA. So you're really going to want to be proactive and just start putting things in place, as well for the safety of the technicians.
One question is, do you provide a lot of this, the materials like the color fobs or the mirror signs, those kinds of things? Do you provide that?
No, we don't sell any of those things.
Okay. Is there a place? I mean, do the warehouses have that? The Medcos?
Yeah, I mean, if you go to like Granger or maybe I know Honeywell has a lot of the EV stuff.
All right. Well, we don't have any other questions. Thank you everybody for your time today. And as I said, I'll follow up with you all, send you a copy of the presentation and the recording in a couple of days. And we'll be in touch with future training opportunities. Kevin, thanks for your time today. And thanks everybody.
Thanks everyone.
Joining us.